In this video, we're going to solve generate parenthesis, and this question is also known as generate all balanced parenthesis. In this question, we are given with the integer n, and we have to generate n such pairs of parentheses, and they should be balanced, which means if an opening bracket exists, then there must always be a close bracket for that opening bracket. So see, if n is equals to 1, that is one pair, then one opening bracket and one closing bracket. Okay. When n is given as 3, then 3 opening bracket, 3 close bracket. Here also 3 opening, 3 close, 3 opening, 3 close. And these are different, you know, permutations by which can n such balance parentheses are generated. Okay. So we are going to solve this question using recursion. So first of all, I will create so the first thing to note over here is as much opening bracket there are, which is equal to n, so is the number of closing brackets, which means we are given with n, but number of opening brackets will always be equal to 3, which is n in our case, and number of closing bracket will also be same as n. Okay, so why don't we create two variables, open and close, which are always equal to n. Okay, now n is given in input. Now I create an empty list in order to hold all the results for n value, and I will create an output. As we know, in such questions, whenever our input becomes zero, where input becomes empty, then at that level of tree, we get our results in the recursion. Okay, so I will be using recursion over here. As I said, so I'll create a utility function which will include open, close, and then out, and then li, which is empty list. Okay, now first base condition is if input is 0, that is number of opening brackets are 0, and along with that number of closing brackets are also 0. In that case, we have reached our base condition. We'll append li with the value what out. Okay, out will get calculated as we go ahead in the equation, and we'll just return out of here. Now this is the base condition. Apart from that, as we know, there will be n number of opening brackets and n number of closed brackets to begin with. And as we move ahead, our problem should always start with opening bracket. I mean, you can see for n equals to 3, there are 5 such possibilities, but none of the solution is starting with a closed bracket. That's not possible, right? For an opening bracket, there will be a closed bracket, but if string starts with a closed bracket, it can never be, you know, a balanced parenthesis. So if we discuss like if open is 0, but what if number of open brackets is not equal to 0? Then in that case, I will create another variable op1, which will store same as out. Initially, it was empty list, empty string, but it will change and get calculated as we move ahead in the problem. And since it is an open bracket, I will append I will append to the string this empty bracket value. Now, nothing apart from this. I just need to recall this function once with op minus 1. Why opening minus 1? Because we have already included one parenthesis over here, then close, and then in place of output we are using op1 because as we have seen we are using this thing, and obviously list to store the result. If that's not the case, and if close is greater than op, why will this occur? Because as we said, we'll start with op, which is open bracket. Okay, now let's say there are 3 opening brackets and 3 close brackets to begin with, and we have started with, let's say, this one. At this place we have used one opening bracket. Okay, so number of opening bracket will get reduced to 2, but close bracket will always be, I mean, at this point will be pointing to 3. Okay, now since close bracket is greater than opening bracket, which means an opening bracket exists, and subsequently a close bracket for that opening bracket is not present. So we'll move ahead with the problem. I'll again create a value called op2, which will store output to begin with. And since it is a closing bracket, we are closing brackets situation over here. So I will add append and closing parenthesis in this op2. Again, I will just need to call this function once. And since we are not providing op opening bracket, so will not decrease the op, but we are adding a closing bracket, so we'll decrease one closing bracket. And apart from that, in place of output, we'll be using op2 and list to begin with. Now, this is what we needed. I will just pass the parameters in this utility function, which is op close output and then list. Now, this recursion will, you may say that this recursion will work like magic and will, populate my list so that I will not return this list. Let's run it for the example test cases. And yes, they are getting accepted. Let me submit it and see how much time complexity it takes. Okay, so it's beating quite less, but this is some problem with LeetCode. Otherwise, earlier I solved this question with 38 milliseconds only. Okay, so let's see, this time memory complexity is same, but the time complexity is taking like almost double. So 1.5 times. So this is not correct way. Earlier it was solving like 75-76% faster than Python 3 results. So I hope you liked the video. Thank you. Have a nice day.